Yeah, and now that we've spoken about code migration, let's also talk a little bit, just a little bit about code generation, because you can not only migrate the existing code, but you can also try to automate some of the steps. So testing is a huge part of the software development journey. So you need to create automated test cases so that you are sure that your software is doing whatever you'd like it to do. And in order to do that, you have to, up until now, write manual test cases. These are so-called unit tests. And this is a large part of the development practice. But to a certain degree, you could also use AI to migrate, to automate this approach and to come up with something automatically. And this is also what we did within our work. And all of these things, all of this, what you just saw, from a simple chat interface to the complete generation of code, all of this can now benefit from rolling your own LLM, which we'll get to in a second. But let's have a look at the outlook, because we really thought, hey, let's take this to the next step. And this is what our next steps at TNG will also look like. So we will have a look at video and world generation models. World generation basically means that you create a video of the real world with which you can train robots, and a robotic foundational model can then be used to really steer a robot. And we really invested like 50,000 euros, sent them to China, and we are now waiting and hopefully also getting our robot at some point in time so that we can also kick him like this unitary robot is kicked in the video.
We will not going to kick him, because you have to remember, always be polite to large language models, and it's always this funny observation that people say thank you and please to their AI. But here you see the Unitary G1 robot, which is basically on purchase in the internet. You just have to provide your credit card number, and they promised they sent us one. So we are happy to share our experience if it arrived. How much fun it actually is,
next year. Right. So what are the ways to really host your LLM? So how can you leverage the power of AI? How can you leverage the power of these large language models? The first of all is, of course, you can use it using software as a service solution. So you basically log into ChatGPT, to Claude, to any provider that you would normally log into, and just start chatting right away. The problem with that is, of course, you are sending away all of your data. The second way of how you can also do this is using your laptop, your desktop computer, or something like that. There are software available like Olama, Olama CPP, or also Whisper for speech to text, with which you can then use your local graphics card and leverage that to really execute these models. Problem with that is, however, that your graphics card is, of course, limited. It's not one of the big ones that you would normally use in a data center. So with that, you cannot really go full scale. You cannot have the full potential of the large language models. So the last thing, and this is what we want to talk about today, is how to provide that in your own data center without too much cost attached. But Christoph, why do we even want to do this?
Yeah, I mean, for us, we can really answer this very simply, because our typical work is for our clients. And so it's not up to us to decide what we can use, but it's up to our clients to decide what to use. And many of our, especially German clients, they don't want their data being sent to these software as a service providers, because if you read the terms with OpenAI, of course, they store your data, they use the data to train their networks. It's understandable, but since you can also hack AI, and there are many proofs how you could regain the training data from trained LLMs, there is a huge issue here. I mean, it's also, in a way, also a European perspective, because, the Europeans, we are the masters of regulation, and the inventors of GDPR. We all love GDPR because we can now surf all the internet. We cannot surf the internet without clicking away all these privacy banners, yeah, that you all know. But for a European company, currently there is the EU-US data privacy framework in place. So you basically, if you want to data transfer GDPR in a compliant way, you need kind of certified US providers. And basically all the big hyperscalers and OpenAI and all of those, they are perfectly legal from that perspective. But the history shows that there's always problems with those kind of regulations, because how could you kind of prevent that certain foreign institution get access to your data? So the current framework replaced the previous Privacy Shield framework back in July 23, which replaced Safe Harbor. So you see there's much movement in that area. And this is really something that that forward-looking in a way reduces the risk to be affected by changes in those regulations. And it's also the other way around in a way, because if you remember, currently we look at Llama 3.3, the open source large language model from Meta. Previous to 3.3, we had 3.2, which was a multimodal model, which means not only with text interface, but also able to generate videos and such. And this model, Llama 3.2, was actually forbidden to be exported into the European Union. Okay, so you see, it's always a complex discussion on a legal side. Of course, self-hosting does not make sense if you're not allowed to use the model. But happily, there are other models that we can use, and that's what we are going to do and show. So typically, all the open source models, they share something in common, namely the open weights. So that's actually what you need to run the large language model on your own hardware. So Mistral, Meta with Llama, Qwen, and DeepSeek from China, they all have this. DeepSeek, in a way, R1 was really a game changer, because they also provide the software and tooling to be able to fine-tune and retrain the network. And they also wrote a very detailed paper on how they trained DeepSeek R1 in the first place, which gained a lot of attention. And so the only one missing basically, it actually is that someone really actually goes the full way and open source also the training data. This has not happened so far to our knowledge, but we guess it's the next step. And if you see how DeepSeek and the release of DeepSeek like shocked the whole AI world, especially the Silicon Valley US tech scene, even Sam Altman made a bold statement about maybe he's on the wrong side of history with his OpenAI open source strategy. So you really see there's a lot of going on. And if you want to really dive deeper into the world of open source, large language models, data sets, and fine-tuned models and all of that, Hugging Face gets you covered. Yeah, it's like GitHub. It's a centralized place where people publish models, data, and everything. And there's also always this huge benefit of using open source software, not only now with AI, but forever. Like, think about Linux operating system and such, because if you have the software, the source code to your software, which is basically one of the important parts of a software being open source, that you actually can get access to the source code, you can modify it. Yeah. And Thomas, how can we use this modification possibilities in the large language model?
Yeah, absolutely. So you have full control over the model, so you can actually try your own experiments on this. And this is what we did for example, with DeepSeek R1. DeepSeek R1, there you can fine-tune the parameters within the model itself, and then you can also try to get something in or get something out. So, for example, you can amplify some specific patterns of behavior, or you can tune them down. And we did exactly that with censorship, actually, for one of these models, namely the DeepSeek R1. And if you have a look at the archive link that is down on the left side, you can see what we did with that. And all of this is, of course, possible with these large language models. And that's why we tried to alter our strategy a little bit, because back in the days we were always like, we'll move everything to the cloud to get down on hosting our own things, to have everything in our basement. So this was not a sustainable model back then. But nowadays, also when it comes to costs, just hosting your own data center with graphics cards and everything is less expensive actually than going to the cloud and doing everything there. And that's why we changed our strategy a little bit.
Right. And in a way, it's also something that we see with our clients. If I think back the last 10 years, there was this huge digitalization programs, bringing everything, the whole IT infrastructure from on-prem to the cloud. But in a way, many of our clients now realize that being a customer of an hyperscaler like AWS, like Azure, like GPC or so, it's a new form of vendor login, because you have to pay the bill for the services. You can expect that the prices raises every year. And so the total, like the mantra, like put everything to the cloud. We see the first clients here, at least in Germany, that are rethinking that approach and really look carefully into which services actually do you put into the cloud, and is there maybe something that you want to roll back into an on-prem scenario. And there are also many local cloud providers, that you may not know in the world. There's Stackit, for example. It's a German cloud, basically created by a supermarket chain, or the group behind the supermarket chain. And it's really impressive what they did. And they guarantee you privacy and also good prices.
All right, so let's have a short look under the hood and what we really have in our basement. So here you can see a happy managing partner of TNG playing around with hardware. And this is one of the first nodes that we really installed. So basically, these machines are pretty huge. They have a lot of memory, but the most important part is, of course, this one, and these are our graphics cards. So for the large language models, for the large language models, you really need something like the NVIDIA H100, which comes with a lot of video RAM that you need to run these LLMs. And we have 3 nodes with 8 of these graphics cards for each of these nodes. So in total, we have 24 of these graphics cards. And then there's also the possibility to run smaller things. So something like image generation probably mostly runs on smaller nodes as well. For this, we have RTX 4090 graphics cards. So the gamers might know that, but it's also a very good graphics card when it comes to AI inference. And then, of course, you also need something on top of that. So you need some storage to really store all of these things, which come at the cost of a few hundred of gigabytes for each of these models just to download them, and you need to really store them somehow. And what you also need is a good interconnectivity between the nodes so that you can also run a large language model on multiple of these nodes at the same time. So for the largest ones, you really need not only one of the huge machines that you see here, but actually 2 of them. And for that, you need some connectivity as well. And then there's also some more involved things, like here on the left-hand side, you see basically status display of our things. And the interesting thing is the one that you see in the red circle here. So it takes like 278 watts at the time, and the peak the peak power that it takes is basically 350 watts. And this is one of the not so powerful graphics cards. So you could have something like 1,000 watts per graphics card, and we had 40 of them in total. So this takes a lot of power.
To put this into perspective, I mean, it's like a hairdryer, yeah, in the range of a hairdryer, and actually in the data center, it's also very noisy because of all the fans. Yeah, it's really something that takes a lot of energy.
And that's why you also need to think about electricity. So for power supply, you might need to talk to the electrician and come up with a more powerful supply in your basement as well. And of course, what is also important is cooling, because all of these things produce a lot of heat. So you need to have a very good AC in the room in order to not get too hot in down there.
Yeah,
all right.
At the end, you have to decide what hardware to use. If you want to roll your own LLM, not GPU is not a GPU. There are different form factors, like you have the classical PCI Express cards that you may be aware of your home computer, home desktop, or you have the server PCI Express modules. They come from different vendors. I mean, most known, of course, NVIDIA, but also Intel has as GPUs, and also AMD is entering the market. Actually, we are trying since a year now to get AMD GPUs.
It's really hard.
It's really hard, yeah. And it's also hard to buy NVIDIA cards. I mean, we have this 24 cards, as Thomas just told you. I mean, one card for 25,000 euros, yeah. Think dollars, yeah. So it's an investment from 1 million euros to have these 24 cards in our data center. And it's not like that you go to Amazon and say, here, H100, 24, buy now credit card. So it's really a hassle to get them. Yeah, it's always impressive if you get the numbers, like Meta invests billions into data centers, AI data centers. You really need a direct contract to NVIDIA to be able to do that. And NVIDIA is also a shareholder of maybe OpenAI and others, because you need this partnership to be able to scale this at large. And by the way, there's also funny paper documents assigned that you have to sign, so it does not feel like the typical hardware shopping. Yeah, you have to sign like the terms. Actually, yeah, you're not allowed to do anything with your cards. You have to sign export controls, so you're not allowed to send your H100 card from Germany to China, for example. Yeah, so there's a lot of things going on. Yeah, but Thomas, you talked about how different GPUs serve different purposes. How can we talk about performance then?
Yeah, there are things to consider when it comes to performance, because you should really measure what type of graphics card you really need. So for example, here we have the latency per token. So this is basically the time you need until you really produce something useful in your LLM. So you have this typewriter effect. So basically the words start showing up whenever you type in something and your chat is responding. And so the lower this time to your token is, the faster you will get your answer, actually. And this is why we need to consider that across different hardware. And here you can see the different hardware, how it behaves basically with different graphics cards. So you have the NVIDIA H100, two of them actually here with one of the green lines. And as you can see, the RTX 4090 is even a bit faster than the NVIDIA H100. But it also comes with the price that you need 8 of them to really run your LLM. So you should really consider this when investing into your data center. So what kind of hardware do you need? And for that, you also need to benchmark it. Speaking of benchmarks, there's also a benchmark for the models. So now you should also consider which models do you really want to host. Each of them behaves a little bit differently. So when it comes to, for example, writing or role playing or reasoning or maths or things like that. So for this, we created a little benchmark, and here you can see that the different models are really a little bit different. So let's get to the conclusion now.
So what we just wanted to show you is running your own LLM is definitely doable. Yeah, it's you can buy the hardware, you can use open source to build it up. You will be independent and have a pretty good data privacy, or at least you can fully control your data privacy. You choose the right hardware. Be aware, you have to spend a lot of energy, and cooling becomes a thing. And you have to use the right models for the job, yeah. And yeah, but we can tell you it's fun. Thank you for listening to us.
Thank you.
Thank you, Christopher and Thomas, for your presentation here. I think we have one last comment from Edward, and we'll continue.
No, it's not really a comment, but I hardly saw I saw your faces glow up when you're talking about the hardware. We were having a lot of fun. You were showing it like was your firstborn baby with all the stacks of drives. So that was pretty cool. So
I can still remember the first computer I got, Christmas 1983, and it makes me cry. Yeah. It's a nerd world. Thank you.
The word nerd was dropped a couple of times here at the table, but that was behind the scenes.
Thank you, Christoph and Thomas.